Section 9.4, you know, I love it. It keeps getting more and more fun. Come on, it's lots of puzzles. It's great. All right, we're going to solve systems with 3 variables. Do you remember I told you that systems are sets of 2 or more equations? And so far, we've just been using two equations with 2 unknowns. Today, we're going to use 3 equations with 3 unknowns, and we're going to be able to find all 3 of them. You can so do this. Here we go. All right. Now, I know that these are longer problems, and so please realize that I know that there are only 8 problems on your homework. All right, you can do this. You can do this. Here we go. The first thing is, just like we did when we had two unknowns, I'm going to give you in the first section of your homework, I'm going to give you the 3 equations, and I'm going to give you solutions. And I want you to tell me, is this a solution or not? And the way you're going to find out is, just like you did when there were two equations, you're going to put this x, y, and z. So this is x, y, and z. All right? You're going to put those parts into all 3 equations. And if it makes all 3 true, then it is a solution. If it makes even one of them untrue, then the whole solution is not a valid solution. So here we go. For the first one, x plus y plus z equals 3. Put in x, y, and z. So 2 is our x, plus 1 is our y, plus 0 is our z. Does that equal 3? 2 plus 1 is 3, and 3 equals 3? Yes. So far, so good. Keep going. So 2 times x is 2, plus 3 times y is 1, plus 2 times z is 0. Does that equal 7? All right. So 2 times 2 is 4, plus 3 plus 0. Does that equal 7? Yes, it does. We're good to go. Keep going. So now 3 times x is 2, minus 4 times y is 1, plus z is 0. And does that equal 4? Am I going too fast, or are you getting it? it's the same thing as when we did 2 of them. We just have 3 numbers to deal with. So now 2 times 3 is 6, minus 4, does that equal 4? Oh, 6 minus 4 is 2, not 4. So this is not a solution. So let's go to the other one. Let's check it out. So we've got 3 is our x, 1 is our y, and negative 1 is our z. Same thing. X is 3, so 3 plus y, which is 1, plus z, which is a negative 1, so it's minus 1. Does that equal 3? So 3 plus 1 is 4. 4 minus 1 is 3, so that is a true statement. So far, so good. 2 times x is 3, plus 3 times y, which is 1, plus 2 times z, which is a negative 1. We want to know, does that equal 7? All right. 2 times 3 is 6, plus 3 times 1 is 3. 2 times a negative 1 is negative 2. Does that equal 7? 6 plus 3 is 9. 9 minus 2 is 7. We're good to go. So far, so good. 3 times x, x is 3, minus 4 times y, y is 1, plus z, which is negative 1, so it's just minus 1. Does that equal 4? All right, let's check it out. 3 times 3 is 9, minus 4 times 1 is just minus 4, minus 1, does that equal 4? 9 minus 4, 9 minus 4 is 5, 5 minus 1 is 4. Yes, so this is a solution. All right, so you'll test each one, and then your final answer that you're circling is either yes or no. All right, so in this case, I marked it off no. This one is yes. Easy sneezy. Okay, let's go to the fun part. Now, on these, I gave you a solution, and you're just supposed to check to see, well, is it a solution? Now, I'm going to give you a system of 3 equations, and I want you to solve it. We can do this. Here we go. What we're going to do is we're going to use elimination but it's elimination on steroids. This is so fun. You can do this. All right, so we've got x plus y plus z equals 2, 2x plus y plus 2z equals 1, 3x plus 2y plus z equals 1. So in order for all three of these to be true, what's happening is these are all planes, and these planes are all going to cross in one little point. All right, and so let's find that point where they're crossing. Here's our steps, and once again, they look big and crazy. Go ahead and write them down. Pause a little bit and write them all down, and then I'll show you step by step where we are in the process so you can mark it in your notes, okay? So step 1, eliminate one variable in 2 sets of the equations. So what you're going to have to do is this. You want to take all 3 of these equations, you're going to choose 2 and make one of the terms disappear. And then you're going to choose 2 different ones and make that same term disappear. So the way you're going to choose this is really however you want to. If there are any terms that don't have any coefficients, that's the place to start. That would make it the easiest. I don't see any that have no coefficients. I do see this one. We could make the y disappear pretty easily here because you've got just a positive y and a positive y. So if we use these 2 together and we multiplied either one, let's multiply the bottom one by a -1. So let's keep this one, x plus y plus z equals 2, and we're going to multiply this by -1. So -2x minus y minus 2z equals -1. So when we and remember when we did elimination, we just add those together. So now this becomes +1 minus 2 becomes a -x. The y's drop out, which is what we wanted. And then we've got minus z equals 2 minus 1 is 1. This is a 2, not a z. Whew. All right, that's the first part of step 1. The second part, remember it says in 2 sets of equations. So now you're going to take the second 2. Now you've got to look for the y's. You made these y's disappear. So now let's put the first one and the last one together. And multiply the top one by -2 to make it match up with this 2. So let's multiply this one by -2. And let's put it over here. I was going to put it over here, but I wrote too big. So let's write smaller here. Here we go. This one times -2. So -2x minus 2y minus 2z equals -2 times 2 is -4. So hopefully you can see it. If not, I'll read it again. -2x minus 2y minus 2z equals -4. This one we're going to keep the same. 3x plus 2y plus z equals 1. And then we're going to add these 2 together just the same way we did these. So we add this and we get just x. Our -2y and +2y drop out, which is what we wanted. And -2z plus 2z is -z, and that equals -3. So now, after step 1, you should end up with 2 equations with 2 unknowns. All right, so now this is exactly what you just did in the last section. You've got 2 equations with 2 unknowns. So now you use these 2 equations, and if you look in this case, you don't even have to multiply by anything because the x and the -x are going to drop out. So you can just bring this equation right down here under here. X minus z equals -3, and just add those together. The x's will drop out, and you have -2z equals -2. Divide by -2. So z equals 1, and you have one part of your solution already. All right, so we eliminated one set of variables, or one variable in 2 sets of equations. That's step 1 here. So this is step 1, all of that. And then use the 2 new equations to eliminate a second variable. This is step 2. We got rid of a second variable, so we just have one variable here. And step 3, we solved, and we got one variable already. We have one answer. So now, Step 4, put the value into one of the equation that only has 2 variables and then solve that. So now we have z. We can't put that into here because we wouldn't know x or y. We would still have 2 unknowns. But if you'll notice, both of these equations that we came up with just have 2 unknowns. So take your z and put it back into, I'm going to put it into this one just because my x is positive. It doesn't matter. You can put it into either one. So I'm going to put my z into this equation. So I'm going to say x minus z, oh, and z is just 1. So x minus 1 equals negative 3. Add 1 to both sides. So x equals negative 2. And that is step number 4. All right. So now once we have 2 unknown, or we have 2 variables, well, we have 2 variables, we can put it into any of these 3 equations. So that's the last step. Put 2 of the known variables into any of the original equations to solve for the third variable. I'm going to choose, in this case, I'm going to choose the first one simply because there are no coefficients, and that just makes it easier. So I'm going to put both of those into this equation. All right? So x is negative 2 plus y is the one we don't know yet, plus z is 1, and that all equals 2. So then add 2 to both sides. So y plus 1 equals 4. Subtract 1 from both sides. Y equals 3. And now I have my total solution. All I have to do is put it together into a point format. Make sure it's x, y, z. Make sure it's alphabetical. X is negative 2. Y is 3. And z is 1. And you're finished. No problem, right? I'm going to make sure I got it right. Huh? I sure did. All right. So all you have to do is don't get overwhelmed. All right. Really and truly take it one step at a time. Step 1, get rid of one of the variables. All right. Get rid of one of the variables in 2 sets of the equations so that you end up with 2 equations that just have 2 unknowns. Then it's just exactly like what you just did in the last section. Get rid of one of the variables in these 2 equations. Then you have one solution. Then once you take that solution, plug it back into one of the equations that just has 2 unknowns, and you'll get your second variable, your second value. Take those 2 pieces and put it into any of your original equations, and you'll get your third piece. Easy. All right, I'll talk to you later.